Let's start with one of the most important building blocks of perspective drawing for product design, our proportional square and cube. And we do this first in 1-point perspective. So the first thing we're going to put down is actually a horizon line. And maybe somewhere identify a vanishing point. Now from this vanishing point, I construct myself down a perfect 90-degree line. So it's perpendicular 90 degrees. And at the bottom, that's for example where my cube or my square should start. I put another horizontal line. And also here, 90 degrees. Then, for example, I can construct myself a nice diagonal. And the next thing that's a little bit tricky, I have to judge a little bit the distance. For example, there. And it's really important when you do this that actually, if you want to have a 1-point perspective cube, you directly see from the front that these distances are all actually equal. And I will show you why that's important in the next step. So in step 2 now, we have to kind of guess how much does this cube foreshorten in perspective. So for example, is that a cube? No, too short. Obviously, that's not a cube either. That's too stretched. So you have to develop a little bit of a sensibility for you what seems to feel correct. And in 1-point perspective, it's a little bit tricky. The problem we as humans are faced with is in our mind, we know this proportional square, but we have to draw it in 1-point or 2-point, 3-point perspective, artificially foreshortened, and we have to guess kind of like the foreshortening, how much something gets smaller the further it goes to the vanishing point. And this transition from how you know how a square looks and how you have to draw it in perspective is quite a challenge. And the main reason why at the beginning you might struggle to guess the correct foreshortening is simply you don't know it yet. You didn't memorize it yet. And there are two very easy tools. You could either use a camera and reference cube and a reference square and take photos of them. And then compare the photos. How, for example, does a cube or a square change its perspective foreshortening based on the view angle you take the photo from. The other option is, for example, to use 3D software, which gives you quite a nice feedback because 3D software uses most times 3-point perspective. So it's actually very similar to the way how we construct things in 1-point, 2-point, or 3-point by hand, which means it's not really the same way how our eye sees it. Our brain actually adjusts even visually what we can see, but the 3D software is more closer to the way how our construction in 2-point or 3-point perspective works, which is actually a simplification of reality. So, for example, here you see I have a camera. There's my camera. And I have my horizon line here and my vanishing point. So the horizon line is also equal to your eye level. So I'm going to create a plane. And just to show you that this is a proportional square, there it is. And let's check out what happens if, for example, I move this plane up. And I make copies. And you see actually that the more I move this one up, and the same also if I move it down, the more I move them up or down, you start seeing more of that surface. Okay. So if we go back to here, you see the struggle is when you see something, something like this, you try to tend to draw it this way, and that's simply not correct. Your brain is actually fooling you. And that's why it's good to do those test photos or test studies, so you start memorizing how stuff simply has to look. Because in one-point perspective, it's really difficult to construct a cube accurately. Later, I'm going to show you how to do this in two-point perspective. But you will see there those constructions are labor-intensive and they have to be very precise. So key here is you need to develop a natural instinct to how stuff has to look from a certain viewpoint. And based on the Blender model, maybe something like this might be okay. Now actually, let's go back to Blender for a second, because I would like to show you something else. So if, for example, I move this square down and down and down, you start seeing what's happening. It gets actually very distorted. So this is actually outside what we would call in perspective drawing the cone of vision. So that's kind of like, maybe let's visualize it this way. Think about it like a circle, and everything that starts getting out of the circle is increasingly getting more distorted and is going to result in an undesirable effect. So we don't want to do that. But this will actually be more important for two-point perspective. So let's say I would like to draw actually this square more at my eye level. So for example, I'm simply putting up some left and right lines. And for example, then let's say maybe here I put down my lower edge, and then just to make quickly straight lines, I'm going to use the line tool. And then based on the video and now this distance, the more actually this line gets closer to the horizon line, it actually has to get smaller. So for example, here is now my square. And of course, you know, when we put it right on the horizon line, all we're going to see is just this line. Okay, let's start actually constructing a proportional cube in one-point perspective. We already have established the ground face, so we have the front and the back edge. That's establishing the depth, and we have the left and the right corner. All we need to do is basically now creating verticals. And what is important is that this line is equal long as those two, or actually what I should have said is those two lines are equal this line, because in a one-point perspective view, the front face of a cube is not perspectively distorted. One-point perspective is actually a useful perspective for certain views, but it's not necessarily like 100% accurate view. So here comes in handy our ability to guess somewhat a proportional square. That feels good. Okay, and then I quickly now can put in my missing upper left and right edge. That's perfect. Okay, so I'm nearly done. I have my depth established with this back horizontal line, and where this line cuts actually diagonal, I put up another line till it cuts the upper diagonal there. And then to check if your cube is perfect, if these two lines here actually touch, I'm a little bit off, then you're good. Okay. And that's basically nearly everything into how to create from a direct front perspective a proportional cube in one-point perspective. And if you pay attention to, again, just to reinforce it, you see how small and that surface is compared to this surface. So again, the more something gets closer to the eye level, it flattens, and the more something gets down away from the eye level, the more of the surface you see. Let's double check that theory again in Blender. Here you see I have a cube, and obviously because the cube is centered along my horizon line, the top and the bottom faces are equal. But let's see what happens if I move this one down. You see the upper face collapses, the lower face you see more, and reverse, the lower face collapses, the upper face you see more. And maybe at this point you start noticing, hey, this actually looks like a room. So here a baby is laying on the ground, and here, yep, Spider-Man had an accident and glued himself under the ceiling. This is actually also the way how you could easily establish the correct eye level room ratio if, for example, you want to make a drawing inside a house. So let's say we define this is our eye level. Now horizon line always is it. So you can research what's the standard eye level. I, for example, am 6 feet 4 tall. Let's say for the sake of simplicity, this is 7 feet. Germans are tall. And let's say this room should be 10 units tall. Then what I need to do is I need to focus either on this line, the front. I can do the same also in the back, and actually start breaking it down into smaller elements. So for example, down here I have 0, here I have 7, there I have 10. The thing about 1-point perspective, same also in 2-point perspective, 3-point is different. Vertical lines never change the distance. 1-point perspective, horizontal lines, we can perfectly measure. So that's a nice thing about this 1-point perspective approach. You can use a ruler in measurements, because in 2-point or specifically 3-point, everything foreshortens, you can't do it. So the trick basically now is figuring out, when we say I'm 7 feet tall with my eyes, what distance here is equal 3 feet and what distance here is equal 7 feet. And you see then basically you have to break it down and then accordingly adjust the height position of your cube. And that's basically it. So let's go to Chrome. Here, for example, you see a record player from Dieter Rams, pretty famous German industrial designer. And you clearly can see, hey, this is actually 1-point perspective. No, it's actually not. It's simply a 3-point perspective, but shot in a way that it looks like 1-point perspective. The reason why this is not 1-point perspective is the verticals actually converge a little bit. But we can easily draw this 1-point perspective. So if we go to Sketchbook Pro and, for example, here put down our horizon line, midline, there, something up, there, and zip, zip, zip. And let's use our eraser. And there it is. You see? 1-point perspective. And I'm cheating with 1 point by making the verticals perfectly vertical and not converging. Now, let's go to the next photo. So that's actually a photo from the top straight perpendicular down. Now, how do you do this? Well, you put this record player on the table and go above it and shoot down. But I actually start drawing it exactly the same way. So what I would do in this case is simply this. So let's make a line, zip, zip, go up and go up, go up, there and there. So you see actually I cheated a little bit, so my horizon line should actually be more there. And then I would draw the rest in. So you see actually to get this photo drawn by hand, I actually on my paper kind of like cheat by rotating the piece a little bit. So here, for example, is my cube. Then let me erase this a little bit. Okay, in all these lines which I'm hatching right now, those are hidden lines in the background. This is sometimes a little bit difficult for beginners to understand, that this is one point perspective, drawing this the piece like looking down, but you can't really one point perspective draw the way how you would make the photo, because in real life I would take the photo and point the camera down to the ground. One point perspective, I have to draw it horizontally to the horizon line. So I simply rotate my object. And that's the whole trick you have to do. Let's go to here. Let's actually copy this image. So you see this is actually a space, also one point perspective. There, new drawing, paste in. Okay, good. So see, for example, there I have a line. Also there I have a line. So this is also a really good exercise when you actually have something like a photo. So draw these grids on it, and you start really seeing how, for example, or where the camera was. So somewhere here I must have actually my vanishing point. So this is actually kind of like a one point perspective. I think the photo got straightened because these edges are really vertical. So it could have been maybe with a telezoom or so, or maybe in Photoshop they adjusted the lens distortion. So also be careful of that one. Let's go back to Chrome. Here I have another interior drawing. And there, for example, you see what I was talking about with eye level. Here's my cube, so my eye level, distance, feet to eyes, eyes to ceiling. This is again everything inside one cube, and you see everything converges at the vanishing point. So what we can do a little bit to make this rather boring looking one point perspective drawing a little bit more informative, because I can't really see what's left and right, we can actually move the object left or right, so we have a little bit of a parallel shift. So let's go to Sketchbook Pro, make a new drawing, and for example what I'm going to do is, here's my vanishing point, and I put my first line down to here, and I do this on purpose, really strongly distorted, and there actually you already can see whoops, how much, for example, now you can see also the side. Let's go and use the eraser and remove these parts. Doesn't exist. And there should be a line. And ooh, there should be a line. Okay, perfect. So there you can see now in this drawing, I would have, if I actually erase maybe these lines a little bit, then it's easier to see. I have three faces now: front face, top face, and either the left or the right face. You can actually only do this effect a little bit. So move it from this point, so the mid-center where your vanishing point is, only a little bit to the left or a little bit to the right, because if you do it too much you will get something like this. So let's do this really quick because we're reaching the end of our instruction. There, zip, 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 and go over, and there, and there you really see that looks really odd. So let's maybe go to here and do the same, maybe with something there. So you see this is still fake, but the distortion is not really as strong and noticeable as here. So again, if you want to do a parallel shift, you can do it left or right, just don't do it too much. Okay, and that's pretty much everything for 1 point perspective of squares and cubes.